Welcome to another podcast. In this episode, we're going to be taking a look at derivatives of logarithmic functions. Specifically, since we know how to take derivatives of exponential functions and we know how to do implicit differentiation, those two things combined allow us to easily come up with the derivative of a logarithm. So we're going to start off with just asking the general question, what is the derivative with respect to x of log base a of x? So this is our general goal. Well, I said we're going to use implicit differentiation, so let's assume that y is equal to log base a of x. This is the explicit definition of the log, or explicitly defined. But I can express this as a to the y, so remember this little trick from pre-calculus, a to the y equals x. And so implicitly, the log is just an exponential. So if I ask you what is the derivative with respect to x of log a of x, that's asking you what is dy dx if I define log ax as y. So I want to find dy dx when a to the y equal x. Well, this is asking me to take an implicit derivative. So the way we do that is we take the derivative of both sides with respect to x, treating y as a function of x. So this y that's here is actually a function of x. And so we know that the derivative of an exponential is the logarithm of the base times the exponential. But then because y is a function of x, I have to also do chain rule on that left-hand side. On the right-hand side, the derivative with respect to x of x is just 1. And so in solving for dy dx, I get 1 over the natural log of a times a to the y. But if you look, a to the y is just x, and so the upshot of all this is dy dx is 1 over the natural log of a times x. So the formula that we've developed here is if I take the derivative with respect to x of log base a of x, the answer is 1 over natural log of a times whatever's inside here. So in this case, it's just x for the base function. So this is my formula for the derivative of a logarithm. Now, in particular, if a is equal to e, so note that if we're dealing with the base e, then this formula for dy dx reduces to 1 over the natural log of e, and the natural log of e is 1, so it's just 1 over x. And so by far the more used formula here is asking what is the derivative of a natural log, and using this formula we can safely say now that the derivative of a natural log is 1 over x. In particular, we're really interested in the case where I ask you what is the derivative with respect to x of the natural log of u, where u is a function of x. This is basically chain rule. If I perform chain rule on that, then the derivative of natural log of u is 1 over u, 1 over x, times, since it wasn't just x, since it was a function of x, I have to take the derivative of that function with respect to x, which is of the form u prime over u. So if we take a second to stare at this, we have another really nice formula here, and that is the derivative with respect to x of the natural log of u is just u prime over u. This is the quick and easy way to take the derivative of functions involving the natural log where chain rule plays a role. And so just as a very quick example of this, what is the derivative with respect to x of the natural log of 5 minus 3x squared? Well, u, in this case, is the inside function is 5 minus 3x squared, and u prime is minus 6x. So the derivative with respect to x of the natural log of 5 minus 3x squared, it's just u prime over u. So it's negative 6x over 5 minus 3x squared. And so that is the very quick and easy way to handle natural logs. Just sort of as one more example here, what if I asked you what is the derivative with respect to x of the natural log of 8 minus, let's say 5x plus x squared quantity cubed? You can very easily use properties of exponents here. Use the property of your natural log here to factor that out. So this is asking, like, what is 3 times the derivative with respect to x of the natural log of just the base? So I just use the property of logs to factor the 3 out because it's a power inside the log. And so now I can easily take the derivative just like I did above. The derivative of the inside is negative 5 plus 2x, and divided by the inside gives us this for the derivative in that case. So don't forget about your properties of logs. They can actually save you a great deal of effort when it comes to evaluating the derivative of a logarithmic function. Sometimes it's best to simplify the logarithmic expression first and then take the derivative. All right, thank you for watching.